Hi, welcome. In this video, we will learn bubble sort algorithm on sorting of big O of n square.
So let's check out how bubble sort works. So, so when you were in school, you were applying bubble sort. Maybe you were not aware of it, like how you were applying bubble sort. But bubble sort, in if I say in a problem solving way, in a simple layman way, it's the simple way how we can sort something, right? And sorting is like really very important to find the data in a particular spot. So basically, when we were in school and when in the assembly line, we need to we need to arrange ourselves in such a way so that it should be a straight line and it should be in a ascending order, right? So from the low height student should be at the first, then higher height student should be at the end of the line. So suppose if you are of class 6, 7th, right, all lines will be same. Right? So we were accidentally applying the bubble sort. We were not aware of it. So what we were doing, suppose we basically compare ourselves with our adjacent adjacent students. So suppose here, like here these and here these are the two students. So if I compare, like if they compare, so he will say something, hey, you are taller than me, so please can you come behind me. So what she will do, she will quickly come behind him. Okay. And then again this girl, now again same thing, will again we will adjacently compare it. Hey, you are taller than me, can you come behind me. Okay, so she will quickly come behind her. Okay, in this way. Again, now here if you can see, here the arrangement is perfect, right? Here the arrangement is okay. Okay, so here there won't be any issue, right? This girl won't create an issue and this boy will also not create an issue. But here this boy will again see, hey, you are taller than me, can you come behind me. So again this will come behind him and it will be like this. Now you can see the whole all the students are sorted easily. So what they have done, basically they have compared the adjacent, right? They compare the adjacent. So suppose when you are in the assembly line, you basically compare from uh, the person that is in front of you. Okay, so you compare with it. Hey, you are taller than me, can you come behind me. Or a person who is shorter than you, and if he is in your back, so what you will do, hey, I am taller than you, please come in front of me. Okay, so this way we basically arrange ourselves in such a way so that it will make a create a very good line in ascending order, right? And the same thing is bubble sort, right? Now let's quickly check with the numbers how we can check it. So now let's quickly check how we can sort this array. So here you can see this array is in completely unsorted array. So this is unsorted array and we will sort it again by using bubble sort, right? So the most important thing that is in bubble sort, or whenever you are explaining a bubble sort definition, you should always know that bubble sort compare the adjacent elements, right? Like we can compare the adjacent students. So basically I compare with 9 and 4, right? I will compare 9 and 4, and here which is the largest number, I will say that this is 9. So this is a bubble, right? A larger number is a bubble. So 9 and 4, and 4 is the smaller one, 9 is the greater one. So if I am arranging in ascending order, so higher value will come to the rights, right? So basically, if any number which is smaller than my 9, what I will do, I will put it here in the left side and my number will go to the right side. So basically, I will keep track that my 9 should move to the right side of it. Okay. So I will compare between these two elements and I get to know that here 4 is smaller, 9 is greater. So 9 will come here, right? Now 7 to 0. Now again I will compare between 9 and 7, right? Which is greater? 9 is greater. So what I will do, I will push 9 to the right. Okay. Now again I will compare between adjacent element 9 and 2, right? And again which is greater? 9 is greater. So I will push 9 towards to the right. So basically what I am doing here, this suppose here 4 and 9 both were in different positions, right? 4 is smaller than 9. So what I did a swap. So all these things are doing a swap. So this is a swap. Basically, we are swapping the elements. Okay. So now 9 is here. Now again, I will compare between 9 and 0. And since 9 is greater, so I will swap 9 with 0. So it will be 9. So after one pass, your array, you can see the last element, the greater element is in the correct position, right? 9 should be here, right? So can I say my one element, my greatest element or my highest element is in the correct position? So this is after pass 1, right? After pass 1, my 9 is in the correct position. So So I don't need to now swap 9 with it, right? Now I am my only array that is remaining is 4720. Okay. So what I will do, I will compare in the next pass 4720. So 4720. Now here I will compare 4 and 7, which is greater. 7 is greater. So and 7 is in the correct position. So no need to swap. So there won't be any swap, right? It will be in the same direction 4720. Now 7 and 2, which is greater? Obviously 7 is greater. So what I will do? I will do one swap. So 7 will come here, right? Now again 7 and 0, which is greater? 7 is greater. So again I will do one swap. So 4207. Now let me add here 9 as well, because 9 is also there, but this is already sorted. My 9 element is sorted. And now I can say my 7 is also in the correct position. This is also in the correct position. Now this much elements are sorted, right? So I will basically remove this one. And now my 2 elements are now sorted. So now I need to work on only 3 elements, right? 4 to 0. So this is something after pass 2, I will say. So this is pass 2. Now let's talk about pass 3. Okay. What I will do, I will compare between 4 to 0 only, and all these elements, right? 7, 9 are sorted. No need to touch. So again 4 and 2, which is greater? 4 is greater. And is it in the correct position? No. So there is a need of swap. So I will swap it. So my 4 will come here. Now 4 and 0, is 4 is in the correct position? No, right? 4 is greater. So I will basically swap it. So it will come here, and I will simply add 7, 9 here, right? Now after pass 3, can I say my 4 is also in the correct position? Yes, it is. So now 4 is also in the correct position. Now again, what I will do one pass 4, and now I need to work only on, so this much is now sorted. So let me put one line here, and let me remove this one. Now I need to work on 2 and 0 only. So 2 and 0, and we have 4, 7, 9 sorted. Now 2 and 0, which is greater? 2 is greater, right? So 2 will come, right? I will do a swap. So 0, 2, and this will be 4, 7, 9. Now can I say my 2 is also in the correct position after this pass? Yes. So this is also sorted. So I will basically say my 2 is also in the correct position. And now see, after only pass 4, my 2 is also in the correct position. There is only one element left, that is 0. So can I say, is there any need of sort? Because only unsorted element is 1. Unsorted element is 1. So can I say my whole array is sorted now? Yes. So the whole array is sorted now. The whole array 0, 2, 4, 7, 9 is sorted. So can you check for 5 elements when n is equals to 5, okay, n is equal to 5, how many passes we have done? Pass 1, pass 2, pass 3, and pass 4. So this is true for n elements. So we got one note here. Okay, my bad. So the note is for n elements, for n elements, we will require n minus 1 passes, right? Passes, you can say iterations, or you can say step, right? So pass 1, pass 2, pass 3, pass 4. So if I say 10 elements, how many passes are required? Only 9. Because you need to sort only 9 elements, right? If one is unsorted element, it is already sorted. All right. And you can also check, one of the question that comes in interview is like, for a in one pass, how many swaps happened? So here you can see we did one swap, 9 and 4, then 9 and 7, 9 and 2, 9 and 0. So here also for 5 elements, when there were 5 elements, only 4 passes we have done, 4 swaps. So 4 swaps needed if the array is completely unsorted. That means in descending order. So if it is in descending order completely, so how many passes you want? 9 minus 1 swaps, sorry. Swaps for n elements. Okay. Similarly, now you can see here, there were 4 elements. There should be 3 swaps. But we exclude one swap here. 4, 7, we have not done the swap, right? Because 7 was already in its correct position. So this one was on swap, this one was on swap. That's why I was saying in descending order. When the whole all the elements are in descending order, then we need to do the like n minus 1 swaps. So this is like depends on the condition. Like they will ask you like how many passes now will happen. Now let's quickly comment over the time complexity, right? So what will the time complexity of it? So here we are not taking any space. We are only using the same array. So the space complexity will be constant, right? I will say big of 1, that is constant. Okay. Now what will the time complexity here? So basically, if I say my n minus 1 is one of the swap that I am doing in pass 1, right? So I am doing n minus 1 swaps, then n minus 2 swaps, then n minus 3 swaps, and so on. It will be something 3 plus 2 plus 1, right? So these will be the number of swaps. And also after this, if I do a complete sum, what will be? This is sum of natural numbers, right? Only n into n plus 1 ki jagah n minus 1 by 2, right? So if I say it will be n square minus n by 2, and by simply ignoring the constants and taking the higher value, we will get a time complexity of big of n square. Okay. So the here time complexity will become big O of n square. So how we got it? Basically, we were checking number of swaps. So this was number of swaps we have done in one pass. Okay. Then number of swaps in second pass. Okay. Similarly, these were the swaps in the third pass. Now let's quickly check how we can create a code of it, right? How the code works. So basically we will do the same, and let's quickly move to the code implementation.